You know, when you're driving, it's pretty seamless, right? You turn the wheel, the car goes. You hit a bump, and you barely notice it. It all feels so smooth, almost effortless. But under the floorboards, there's this incredible, complex dance of engineering going on. Today, we're going to pull back the curtain on the real unsung heroes of your car, the steering and suspension systems.
I mean, really think about that for a second. How does that tiny little movement you make with your hands translate into turning a 2-ton hunk of metal, and with such precision? It's not magic, but what's going on mechanically is, well, it's absolutely brilliant.
And whoa, yeah, look at this. This is what's actually happening down there. It's not just one part, it's this whole complex web of joints, arms, and gears all working together. You can see the tie rods, the steering gear, all of it has to work in perfect sync. We are going to make sense of all of this.
All right, so let's get into it. These two systems, steering and suspension, they're working together all the time, but they each have a very different job to do. Let's break them down.
At the end of the day, it really just boils down to this. It's super simple. Steering is all about control. It's what lets you point the car where you want it to go. And suspension, that's all about comfort, making sure the ride is smooth and you're not getting rattled to pieces.
So let's start with control. How does your command, your intention, actually travel from your hands on the steering wheel down through all that metal and out to the tires on the asphalt? Let's follow that path.
For the most part, there are two main ways cars do this. The first one, rack and pinion, is what you're going to find in pretty much every modern car. Why? Because it's simple, it's light, and it gives you a really direct, responsive feel for the road. The other main type is the recirculating ball system. This one's a bit older, it's a lot beefier, and you'll usually find it on big trucks and heavy-duty vehicles.
Okay, so check this out. This diagram shows us exactly how they work. Down at the bottom, that's your rack and pinion. See that little gear? That's the pinion. It spins and moves that long toothed bar, the rack, left or right. Super simple, very direct. Now look at the top diagram. That's the recirculating ball setup. It's way more complex with a worm gear and ball bearings inside. It's not as snappy, but man, is it tough. It's built to last.
All right, so that's how we control the car. Now let's switch gears and talk about comfort. We're not focused on what the driver is doing anymore. Now we're talking about what the road is doing to the car. How in the world does your car just glide over all those cracks and potholes?
Well, the suspension basically has a 1-2 punch. Its first job is to absorb the initial hit. But then, and this is just as important, its second job is to control all the energy from that hit so you don't just keep bouncing down the road like you're on a pogo stick.
So that first job, absorbing the bump, that's up to the springs. You've seen these before. Most cars have coil springs, a lot of trucks use those flat leaf springs, but they all do the same thing. They compress, they allow the wheel to travel up and over an obstacle, and they soak up that first big shock.
And the second job, controlling the bounce, that's where these guys come in, the shock absorbers or dampers. Seriously, without shocks, your car would be a nightmare to drive. The spring would just keep bouncing and bouncing long after you hit the bump. Shocks are what dissipate that energy and bring everything back to a stable, smooth ride, keeping your tires planted on the ground.
Okay, so we've got steering for control, suspension for comfort, but how do they work together? The secret, the real magic, is in the geometry. We're talking about wheel alignment, the super precise angles of your wheels relative to the car and the road.
You know, here's a great way to think about it. Imagine trying to walk with your feet pointed way out to the sides, or pigeon-toed. It would feel awkward, you'd have trouble walking straight, and the soles of your shoes would wear out in weird spots. It's the exact same thing with your car's tires.
And that geometry comes down to 3 key angles. People call them the ABCs, but it's camber, caster, and toe. So camber is the top of the wheel tilting in or out. Caster is the angle of the steering pivot point. Think about a shopping cart wheel, how it's angled to want to follow in a straight line. That's caster. And finally, toe is just what it sounds like, are the front of the tires pointing in or out, like your feet. Getting these 3 just right is absolutely crucial.
So how do you know if these angles are messed up? Well, good news. Your car leaves clues. In fact, your tires are constantly telling you a story about what's going on with your alignment and your suspension.
You just have to know the language.
So here's your decoder ring. If you look at your tire and see that only the inside or outside edge is worn down, that's a dead giveaway for a bad camber angle. If you run your hand across the tread and it feels kind of feathery or sharp in one direction, that's a toe problem. And if you see these weird random bald spots, that's called cupping. That's your tire literally bouncing down the road and it's screaming at you that your shocks are shot.
All right, let's put all this new knowledge to work. Let's think like a pro technician for a minute and try to solve a real-world problem.
Okay, here's the scenario. And this comes right out of a professional certification guide. You've got a car that has this weird side-to-side shake, a shimmy, when you're driving slowly. But when you get on the highway, it feels like it wants to wander all over the lane. So, based on what we just learned, what's the culprit?
And the answer is caster. Remember caster? The shopping cart wheel angle? In this case, the problem is too much positive caster. So why? How does that one specific angle cause those two very different feelings?
Well, here it is, straight from the ASE study guide. Too much positive caster creates a whole mess of problems. It makes the steering wheel feel heavy, it makes it snap back too fast, and it causes that shimmy at low speed and the wandering at high speed. It's just a perfect example of how one tiny little angle being off can completely change the way a car drives.
From the little vibrations in the steering wheel to the way your tires are wearing down, your car is always talking to you. It's always giving you information, and now you know how to decode it. So the only question left is, the next time you get behind the wheel, are you going to listen?